In lab 6, we are doing some experiment on spectroscopy. In this lab, we are going to observe continuous and discrete spectra. Before going into actual lab, we have to understand the physics behind it. So let's begin with atomic structure. This is a hydrogen atom. It has one proton and one electron. Electron is going around the nucleus, and one proton is staying inside the nucleus. So this is said to be ground state because the electron is the lowest possible state, that is first orbital, right? When this electron gets certain amount of energy from uh, photons or somewhere else colliding with some particles, it will get excited. That means it will move from this orbital to the next orbital. Okay, here it is going up from first orbital to the next orbital. So this is said to be excited state. Okay, so atom can get excited by two ways. One, by observing certain kinds of radiation. We can say by observing photons, right? It cannot observe any radiations. The energy should be suitable to get excited from lower energy state to higher energy state, right? The other way is with colliding some particles. If atom get collision with another particle, atomic particles or subatomic particles, it will get excited. So there are two ways to get excited from lower energy state to higher energy state. Okay, so this is said to be excited state because electron from this level, which is ground level, is excited to the second excited state, second orbital, right? So this gap is said to be energy gap between these two orbitals, right? Electron cannot excite somewhere between these two orbitals. Once it gets excited, electron cannot remain in the second orbital or third orbital forever. It will get de-excited after certain time. That time is very, very small. Look at here. It will just remain in second orbital, that is excited state, only for 10 to the power negative 8 seconds. Okay, so that phenomenon, when electron get back to its ground state or lower energy state, is said to be de-excitation. Okay, so there are two kinds of spectra. One is continuous and the other is discrete spectra. Example of continuous spectra is incandescent light. If you look at the light, incandescent light, in your classroom or in your room, you can see the spectra is continuous. There is no gap between the different frequencies of light. There is no gap between the color because with the variation of frequency, color of light will be different, right? So in the other hand, there are other spectra emitted from atom that are discrete. That means there is a gap between frequencies of light. Okay, so look at the example. First one is the continuous spectrum, right? There is no separation of different color of light. In second one, in this figure, you can look at the emission spectrum of certain atom, and there is gap between the lines, these thin lines of color. So this is discrete spectrum. So emission line spectrum and absorption line spectrum are kinds of discrete spectra, and example of continuous spectrum is incandescent light. Okay, so to look at these spectra of light emitted from different sources, atomic gaseous discharge or from incandescent light, we have to use a spectroscope. The main components of a spectroscope are shown in this figure. One is slit, this narrow down light beam. So second one is prism, or in place of prism, you can put diffraction grating also. And the third one is a screen or detector, in which you can see spectrum. Whether it is continuous or discrete, we can look at it. Okay, these are important components of a spectroscope. So this is the hydrogen spectrum. You can see the clear four distinct lines having distinct colors. So this gives you the fingerprint of hydrogen. The fingerprint means, this is the unique signature. You can identify this material, this atom from other material, other atoms or molecules, because different atom or molecules have different emission spectral lines. Okay, so emission line provide a fingerprint of the substance being investigated. In this way, if we don't know a particular substance, molecules or atoms or whatever, if we get emission spectra, we can find what type of material that is. We can find the composition. That's why it is a very important technique to investigate atoms or molecules in chemistry and physics. Okay, look at here. For example, in sodium, we can see two distinct lines, spectral lines, at 589.6 nanometer and 589 nanometer. Both are in yellow parts, right?